This comet may be older than dinosaurs, older than Earth's continents, older than anything we've ever seen visit our solar system. 3I/ATLAS could be a fossil left over from the time when the Milky Way was still young. Its chemistry doesn't match the comets we usually find. It whispers of a time before oxygen-rich worlds when cosmic ices were entirely different. What could a relic that ancient tell us about the early galaxy? And why do scientists think it somehow survived billions of years untouched, only to drift past us now? But before we dive in, please hit subscribe and like the video. Your support means the world to us. It helps us grow the community and bring you even more exciting space discovery videos. Thanks a lot. And now let's dive in. What does it mean for something to arrive from the deep dark, appearing suddenly and behaving like no comet we've ever studied before? That was the question when astronomers first spotted 3I/ATLAS. At first glance, it looked like a faint smudge, just another icy traveller making its way around the sun. But within weeks, measurements showed that this was no ordinary visitor. Its path through space couldn't be explained by a normal orbit. Instead of circling our star like the comets we know, it was slicing through the solar system on a path that didn't loop back. That kind of motion meant only one thing. This comet did not come from here. It had arrived from the outside, carrying with it the mystery of another place entirely. That realization changed everything, because interstellar comets are not the sort of thing you see often. In fact, before Atlas was discovered, astronomers had only caught 2 of them. First came Oumuamua in 2017, a strange tumbling shard that raced back into the dark without leaving much behind for study. Then, in 2019, came Borisov, the first true comet we could call interstellar, with a long tail and gas emissions like the ones we're used to, but moving on a hyperbolic path no orbit could contain. When Atlas appeared, it immediately joined this incredibly small list, making it only the 3rd confirmed wanderer from beyond. That sheer rarity meant the world's observatories turned their attention toward it. Atlas stood out even further because of the way its brightness flickered and its orbit shifted. Unlike most comets, which follow fairly predictable fading patterns as they approach the sun, ATLAS flared brighter and then dimmed with unusual instability. Its trajectory suggested it might not hold together well, almost like something already worn down by ages of travel. That instability set astronomers wondering, could it belong to a time frame far older than our solar system itself? Imagine walking along a modern beach and stumbling upon a chipped shard of pottery made by a culture long gone. Atlas felt like that sort of relic, fragile yet revealing, caught by chance in a moment where we could study it. By running simulations of its path backward through time, scientists realized something astonishing. This comet hadn't just brushed past another nearby star before drifting in our direction. Its track pointed further back into a region of space tied not to recent history but to the galaxy's thick disk. That area surrounds the thinner spiral arms where our sun lives, and it's filled with some of the oldest stars in the Milky Way. If this is where Atlas began, then the comet isn't just old. It's ancient, formed during the earliest shaping of our galaxy. Suddenly, the idea of calling it a galactic fossil didn't sound like a stretch at all. But what truly surprised researchers wasn't just where it came from. It was what was locked inside its frozen shell, a story written in ice that revealed an even deeper mystery. What if you could hold ice that froze before our sun even formed? What signs would tell you it was that old? To answer that, you first have to think about what a comet really is. These objects aren't just frozen balls of gas and dust. They are chemical time capsules. The material inside them comes directly from the place and conditions where they formed. When they fall apart or release gas, what's left behind is like a laboratory sample taken straight from a much earlier era of the universe. Most comets we know from our own solar system share a fairly familiar recipe. They are rich in water ice, which makes sense given how common water is in the outer regions where they formed. Alongside the water, there are plenty of carbon compounds, carbon dioxide, methane, and other volatiles that evaporate when sunlight warms them. Those ratios can shift depending on where exactly a comet originated, but water is almost always the main ingredient. It's so consistent that astronomers often use the water to carbon dioxide ratio as a benchmark when comparing comets. With 3I/ATLAS though, the pattern was broken in a way that caught everyone's attention. Instead of the expected water-rich mixture, this comet showed a strange imbalance. There was an unusually high level of carbon dioxide, while water itself seemed much less abundant. That kind of ratio doesn't look like anything we usually see in the comets roaming our solar system. It stood out because you shouldn't expect an interstellar comet to look too different. Comets form from cold ices and dust wherever they are, so some similarities should remain. Yet here was a body that seemed to carry a completely different chemical fingerprint. That unusual mix immediately raised questions. Imagine scooping up seawater, bringing it to your lips, and noticing the salt just isn't there. By all accounts, it should be, but it's missing. That's what these measurements felt like for astronomers studying the gases of ATLAS. If water isn't leading the recipe, something about the birthplace of this comet must have been unusual. And the best explanation lies not in the present-day galaxy, but in its earliest history. Back when the Milky Way was young, elements were distributed very differently. The first generations of stars had exploded in violent bursts, scattering carbon and other light elements, but oxygen levels were lower and heavy elements were scarce. In those conditions, clouds of dust and gas produced ices with a very different balance compared to the ones that later formed in our solar system. Scientists believe the composition of ATLAS fits that picture. High carbon dioxide but low water ratios could represent the kind of chemistry that dominated long before the Sun was born. If that conclusion is right, then this unstable little comet is not just unusual. It's possibly one of the oldest ice bodies humanity has ever observed. If so, 3I/ATLAS isn't simply a travelling comet. It is a frozen sample of the Milky Way's earliest chemistry. But what kind of galactic history does it actually point to? If 3I/ATLAS truly began its journey billions of years ago, then you have to ask what kind of galaxy it came from. To answer that, you need to picture the Milky Way at a much earlier stage. The region known as the thick disk is filled with stars that formed when the galaxy was still taking shape. These stars are older and contain fewer heavy elements, which is the cosmic way of saying they were created out of material that had not been heavily processed by earlier generations of stars. That environment would have been dramatically different from what we see today, both in makeup and in how violent it could be. During those early times, the galaxy was not a peaceful place for fragile objects like comets. Supernovae were far more common because massive stars lived short, explosive lives. The radiation background was harsher, flooding space with energy that could strip gases and damage fragile ices. Chemistry itself was volatile, shaped by the limited resources present in young interstellar clouds. Under such conditions, it would be difficult to imagine a small, icy body surviving for long. Most would either be shattered, melted away, or thrown out of their birthplaces entirely. And yet, Atlas somehow seems to have endured all of this, carrying its chemistry forward into the present. That survival creates one of the biggest puzzles about the comet. If almost everything from that time should have been destroyed, why do we still see this one? It's almost as if it had been protected in some rare, sheltered niche that allowed it to escape the typical fates of collision and erosion. The odds of such a body lasting until now seem tiny. And yet, here it is, moving quietly through our solar system as if nothing happened. The analogy that fits best is a seed from an ancient forest. Imagine that every tree in that forest was burned away long ago, yet one seed managed to stay alive underground until now. Atlas is that lone survivor. If its path from the thick disk is correct, then this comet has preserved chemistry that no other known object can show us. It is like a page of the galaxy's own history book, written before modern stars had even formed. On Earth, researchers have sometimes found fossil meteorites trapped inside ancient rocks. One striking example is a 466-million-year-old meteorite that confirmed the story of a massive asteroid collision in our solar system's past. But what Atlas carries is a record not hundreds of millions, but billions of years older. It is history from a time when the Milky Way itself was new. So when astronomers studied this unusual ice body passing through the solar system, they were not just witnessing another comet. They were seeing one of the very few surviving witnesses of the galaxy's birth. a glimpse into a time before our sun even existed. 3I/ATLAS isn't evidence of aliens or science fiction. It represents something even rarer, a natural fossil from the dawn of our galaxy. By studying it, humanity gains direct access to material older than the Earth itself, preserved across billions of years. These interstellar visitors prove that pieces of deep time still drift through space, waiting to be noticed. With new observatories like Vera Rubin prepared to scan the skies, the chance of detecting many more increases dramatically. Each discovery could reveal a different chapter of galactic history. The question now is, what other ancient fossils are quietly approaching our sky?